extremely important board. When you close your eyes, I want you guys to see this board. When you go to sleep tonight and someone asks you what energy is without even opening your eyes, you're going to be able to say the ability to make things change. So, that is why we added energy is never created or destroyed to our very important board. Now I'm going to go back a little farther and talk about one of the energy stations. Do you guys all get to go to the bouncy ball station?
Yes.
Yes? That wasn't anything new. Everyone's played with bouncy balls, but have you really talked about the physics of what a bouncy ball is? Here I have a tennis ball, which is just pretty much a large size bouncy ball. Can someone tell me what happened at the station? Gabe, I know you're an expert at bouncy balls.
Bounce the ball and then keeps bouncing but never goes up to the original height.
Alright, very good, very good. So you came up to the bouncy ball. The bouncy ball was on the table, right? Did it just bounce there?
So I picked it up.
You picked it up. And what'd you do?
I let it go.
You let it go. By picking it up, what did you give it? Gravitational potential energy. Alright, gravitational potential energy. And this has always kind of drove me crazy because they call it gravitational potential energy. But it's not just has the potential to have energy, it has energy. So I have no idea why they call it that. But anyway, gravitational potential energy. Then what happened?
You dropped it.
You dropped it. And what happened to the gravitational potential energy? Changed into kinetic energy, right? And how do we know it did that? It moved, and then what happened to the gravitational potential energy?
Transferred and then
Transferred to what?
into the ground. And then
Well, even before it
transferred into kinetic energy.
Oh, beautiful. So, and what happened? Tell everyone your thoughts.
Oh, well, it had gravitational potential energy, and then you dropped it, it transferred into kinetic energy.
Beautiful. I love it. I love it. All right. So let's go back again. So Gabe, you said that the ball was on the ground, and you gave it potential energy, right? What is that called?
Work.
Work. And what does work equal to?
Force.
Yeah, in a mathematical sense, but what do you do when you do work on something?
You move it.
You move it. What'd you say? Yeah? You transfer energy. So you either give energy to it or take away energy from it. That sounds like a pretty important definition. Where do you think you're going to put it? All right. All right, so. Alright, so you're sleeping in your bed, your parents come in. Before they wake you up, they ask you, what is work? Greg, what do you say? Eyes closed, you don't sleep with your eyes open.
To do work is to change an object's energy.
Beautiful, okay, so it's on the important board, we know it now. You guys will take it to your grave. So, let's put that up there. The next question is, well, how much gravitational potential energy did I give this ball? Don't answer that. You will ruin my lesson. We'll talk about that. Don't worry about it. So, that's what scientists thought, you know? Maybe, do you guys all know the answer? Yeah, okay. Well, we're going to go through this lesson like we don't know. We're going to, well, no, this is what scientists do. We're going to do this on a very simple scale, but you guys will be able to apply this to all sorts of different things that you don't know the answer to. So the question then came, well, I gave it energy, but who knows how much energy? And the next question is, well, how much kinetic energy did I just give Nate there? Yeah, we don't really know. We don't know this answer. So we have to develop ways of finding out the answer to that question. So to answer that question, I'm going to bring up another question. And that is, imagine me sitting here, and imagine John Papelbon sitting here. Do you all know who John Papelbon is? No? No, he's the Red Sox pitcher, right?
He's not doing very well.
He's not doing very well. So not the most topical pitcher. What pitcher would you like to pick?
Lester.
Lester? Alright.
Yeah,
Who's at the All-Star game?
Yeah.
Okay, so imagine me and Lester taking this tennis ball and throwing it. What ball do you think has more energy? Mine? Gabe thinks mine?
Well, they're the same.
Yeah.
They have the same?
Wait.
No,
Are
no,
they
no,
same
the other guy.
Are they
Keep in mind that the extent of my baseball career is T-ball. What do you guys think?
The picture.
The pitcher, alright. So we're in agreement. My feelings are a little hurt, but I guess we can all agree that Lester probably can give this tennis ball a little more energy. But how would you know?
Because he throws it faster.
He throws it faster. What if your eyes were closed?
You use your radar.
You feel like
You could feel it. How would you feel it?
that.
Yeah. Would you rather get a ball thrown by me or Lester? Yeah, okay, that's right. So that's one of the ways we're going to measure how much energy is in an object. Alright, so now that we've had fun with ball, does every group of runners have a ping pong and a golf ball?
Yes.
Alright. So, I want one partner to close their eyes and hold out their hands. The other partner is going to take the golf ball and the ping pong ball and drop them from the same height. Alright, go ahead and do that. Other partner, do not open their eyes. Try to do it over the table so we don't have... Alright, try it one more time.
He kind of like can't catch.
There we go. I think you guys got the idea though. So, my dude, could you tell me which one had more energy?
The ball.
What was it, the right, could you...
The right.
The right hand, and what ended up being in your right hand?
Golf.
Alright, so, if it hurt more, does that mean the golf ball had more or less energy?
More.
And what is the difference between a golf ball and a ping pong ball? The mass, right? What was that, Matt?
More dense.
More dense, but it's the same volume, so what does that mean about the mass? Bingo. Alright, so what does that tell you about one of the factors that goes into gravitational potential?
Mass.
Mass, beautiful. So, if that's the very important board, this is the important board, okay? So I'm going to put down mass.
Yeah.
Alright, so we're done with the golf balls and ping pong balls. This time, we're going to pass around marbles. Each group gets 2 marbles. If you guys want to put the golf balls back in this.
Please don't miss time.
Interesting marble.
Thank you. What?
Use the ping pong in there.
Two different ones. I need to
Okay, so does every partner have 2 marbles? Alright, so the other person now is going to have their eyes closed and hold out both their hands.
Please don't hurt me.
And I want the other partner to drop the ball from maybe a centimeter height, and then the other one from a much larger height.
Alright.
Make sure it lands in the hand.
Big man.
Okay, so Matt, were you the one closing your eyes?
Yes.
Could you tell which one had more or less energy?
The one that was dropped at the higher altitude because
Well, you didn't know that, right? You just knew that as your right or left hand.
my left hand then.
Left hand. And Nate, was that the hand that dropped it?
Yep.
So, which one had more energy?
Left hand.
The left hand. And what was the difference between the 2 balls?
Nothing.
The height
Oh,
that it was
yeah.
dropped at. So, what does that tell us about the other factor that goes into gravitational potential energy?
Distance.
Height or distance dropped? You guys don't need to know this in your sleep, but definitely when you're conscious, these are the things that you need to know. So now that we investigated gravitational potential energy, let's move on to kinetic energy. And for that, I'm going to need a volunteer. Yeah, one of you want to come up? Alright, you're just going to stand right there. And here I have 2 balls of some sort. Greg, can you tell the class the difference between the 2?
That's my ball.
That's true. Alright, so
Much heavier.
this one, much heavier. Try that. Don't throw it, that would be bad. Alright. So what's the difference between these two balls here?
Wait.
Weight and also, I heard it.
Mass.
Mass, exactly right. So I'm going to roll both of them. And you're going to try to stop them. Keep in mind, I'm on my college kickball team. I'm the pitcher, so just be prepared. All right, this one first. We'll go easy on you. All right, not too bad, right? And I'll try rolling this one at about the same speed. What would you say?
Harder to stop.
That one is harder to stop, right? So what does that tell you about this one? More momentum. What else? Think about what we've been talking about all day.
There's more energy.
View. Yeah, that's the word I was looking for. This one has more energy. And I said that I tried to roll it at the same speed, right? So what does that tell us about another factor that goes into kinetic energy? Don't say it with a question mark. Say it with confidence. Mass. That's right. Because the main difference between the two scenarios was one was much more massive than the other one. So that's going right here. But this is for kinetic.
Oh, right.
So that's okay. All right. Another volunteer. Nate, you want to come up here? All right. Just head over there. So what do you think another factor that goes into kinetic energy is?
Speed.
Speed. Very good. So I'm going to do it slow at first, and you're going to stop it. All right. How was that? All right. Now I'm going to put some heat on it. Oh, very good. Nate, could you tell the class which one had more energy?
The second.
The second one. And how do you know that?
Faster.
It is faster. What if your eyes are closed?
It was harder to stop.
What? Yeah, wasn't it harder to stop? You know, just by a little bit? Yeah. All right. So which one had more energy?
The one with more speed. All
All right, so we drop it. Then, I mean, we did it before. We could feel that one had more energy. But we need numbers, right? We're scientists. Matt.
You measure how many inches off the table you're going to drop a certain ball, and then how many for the other one.
Okay, so you see how much.
Scale.
So we see how much it bounces up.
Yeah.
All right.
I guess if you want to test mass effects.
Well, we're still on height. We'll get back to that.
Oh, okay.
We'll get back to mass. So Matt, if you test how much it bounces up, what if you had like different materials? Wouldn't that affect it?
Yeah.
It's the same material.
So same material,
Just give
The
it
same
outside the
size.
setting.
same size. Let's see where this is my bag of marbles over here.
Yeah.
So you think you'll be able to measure that height?
No. You can measure the starting pressure.
You can measure the starting height. That's very important. So that goes back to what Gabe was saying: is we drop it from different heights. The time.
We could put it on our band and see how far it goes.
Oh,